In order to multiply two matrices A and B to get AB, the number of columns of the first, which is A, must equal the number of rows of the second, which is B. If this condition is not met, we cannot multiply the two matrices. If A has dimensions m by n, and B has dimensions n by k, then the result matrix AB is going to have dimensions m by k. So what that means is, based on the previous condition, the columns of the first matches the rows of the second, which is true. These numbers n match, and the result AB is the two leftover dimensions. So AB in this case would be an m by k matrix. So for example, let A be a 3 by 2 matrix and B be a 2 by 4 matrix. Can AB be computed, and what are the dimensions of AB? So A has dimensions 3 by 2, and B has dimensions 2 by 4. And we need the columns of the first to match the rows of the second, which means these two middle numbers need to match, which they do. So yes, AB can be computed. And then the dimensions of AB are the two leftover numbers 3 by 4. So the dimensions of AB, this is just shorthand for writing that, are 3 by 4. Second, can BA be computed? Now we'll write it in the opposite way. So B comes first now. The order does matter, so 2 by 4 is the dimensions of B, and then A has dimensions 3 by 2. So in order to multiply these matrices, we check the middle numbers. They need to match, but they do not in this case. So can BA be computed? No. And that means that we can't find the dimensions of BA since it cannot be computed. So what this means is that it's possible that we might be able to multiply two matrices one way, so we can multiply AB, but we cannot multiply them the other order necessarily. So we can't necessarily multiply BA if we can multiply AB. So the dimensions and the order matter.